Previously on Physics Fun Time.
Let's just consider everything in time and space is in one continuous line. There's a positive and a negative. Because he started and stopped at the same location, 0 meters, his displacement is 0 meters. Acceleration is the rate at which velocity changes. Welcome back to Physics Fun Time with
Ivan the Elephant!
and the Wizard.
Hey, Mr. Spermwell, how's it going?
Hello, guys. I'm just going to find a cliff. Do you know where a cliff is?
Well, why do you want to throw the ball off the cliff?
Well, I want to see where it's gonna land.
Well, I think there's a cliff over there.
Oh, cool. Thank you.
Well, what was that all about?
Well, he's probably doing an experiment with projectile motion.
What's projectile motion?
Projectile motion is the motion of an object upward and outward.
Huh?
Well, before we talked about movement of an object on an x-axis, but now there's an x-axis and a y-axis. Last episode, we dealt mainly with scalar quantities, or quantities of only magnitude. But now, when we talk about projectile motion, we're dealing not only with scalar quantities, which are velocity and acceleration and displacement and all that jazz, but we also have to worry about direction. These are vector quantities. Vectors and scalars are found prominently in trigonometric problems. The x-scalar and the y-scalar are the two sides that form a right angle. The hypotenuse is the vector, or in the case of a projectile motion problem, the angular direction at which an object travels in motion.
Well, where do we see these vectors and scalars?
Well, we can probably go check out our friend the whale. He could probably help you get a better understanding of vectors and scalars.
Sounds good. Hey, Mr. Spermwell, what you doing?
Hey, guys. I'm just about to throw it up the cliff.
Well, let's see it then. That looked an awful lot like projectile motion.
Yes, so why don't we take a look at that in slow motion? Because the ball is thrown at an angle, the final distance of the object can be measured through the triangles that form the parabola of motion. Using trigonometric rules, this means that the horizontal velocity is equivalent to the initial speed times the cosine of theta, and that the initial vertical velocity is equivalent to the initial speed times the sine of theta.
I wonder if the same thing will happen if we try and push a body off the cliff.
Well, that's an interesting idea.
Guys,